Alright, hello, this is Rafael. Today I'll be demoing my code and my program. So let's get started. First of all, I'm using the shape class as well. Uh, I've created what I'm calling a polygon shape because a triangle is just a type of polygon. And I just wanted to go above and beyond and see what it would be like to implement all of this assignment for all possible polygons. Um, so here's the draw function for this polygon. What it does is using the matrices, pushes it to the matrix stack, calculates anything, and then draws it. And draws what is called a polyline here in Open Frameworks. A polyline is just the lines that describe a polygon. You give it basically a line of vertices, close the shape, and you get your own polygon. Um, After that, here in update, we change the angle of that polygon. You want to rotate it depending in our input vector. So what I did is I created an input vector that has an x and a y. So x would be for A and D, and y would be for W and S. So the WA is the keys and the arrow keys as well. Um, then use the array so that I can basically translate within array this shape. So first I calculate the radians given the angle of that polygon. I did a little bit of offset of 90, and then I just use pi as a constant, set the origin to my polygon, then change this parameter depending on my input vector .y, which is my up and down keys, and my movement speed, and also set that direction to cosine and sine of that angle, which basically gives us units within the unit circle with the radius of 1. And then all I do is change the position of that polygon using this beautiful equation the prof introduced, which is for the ray. So the origin plus a parameter t times a direction. And all I'm doing is changing to this result our current position. That's about it. Here all I do is check for input and set our x's and y's. Here I reset input for x and y in case we stop. And then here for mouse drag, I do the same thing we did before, just drag the shape, check if we're dragging. So I think that's about it in terms of the application. Most of the juicy bits are here. Um, so now we can go into the polygon shape. Let me comment this actually and uncomment this. So like I was saying, I'm using a poly shape to draw just any polygon you want. And for that reason here I'm describing the vertices for a triangle. These don't matter where they are at. We don't need to center them. I center them later. And here you have our polyline, which we use, and our min x, min y, max x, max y, which we use as bounds for calculations further after. So here is the polygon shape constructor, and here we calculate a bunch of things. So I set these parameters in order to find the maximum vertex in the polygon, so that way we can kind of find a bit of a bounding box, you could say. So I loop through all the vertices, find the minimum and the biggest, then I calculate a midpoint. So basically I'm calculating the center of this polygon, and then I'm dividing that by 2 to find the center, and then adding that bit of an offset to all the vertices. And what that's going to do is it's going to center it, so our 0, 0 is going to be at the middle of the shape. And the idea here is you draw your shape going from 0, basically in the first quadrant of the Cartesian plane, which is positive in x and negative in y actually, because of how Open Frameworks is flipped upside down. So that's drawing the well, more like generating the polygon and its vertices. Then for drawing the polygon, we do that over there, like I showed earlier. Right here, yeah, polygon to draw. And then we have a draw function for polygon shape, which I showed earlier. Then over here, we have the insight function, which is the most fun part. Here I actually use the ray casting algorithm. So I looked into fun ways to just be able to work with any polygon and check if we're inside or outside that polygon. I know games like Doom and other games in the past use this technique to calculate it. So what I did here to calculate is use the point P, which is actually in screen coordinates. We have this bool is inside that we return at the end. Then we basically undo the transform that we have given our shape. So we transform it from object space into screen space. Let's go back to object space. and then I multiply that times that point that we're given. And that is basically going to move our coordinates from screen space, which is a mouse position xy, to object space, which is into that shape, that triangle. Then we calculate the number of intersections. And what is fun is you can draw a line from left to right. So you draw a line at some point. Let me actually run this program so I can show. Okay, there we go. Let me maximize this. Okay, so I can actually, if I click my mouse in here, that's gonna draw a line from here all the way to infinity, to the right. And what we're doing is check the number of intersections with the shape. So if I'm inside and click here, there's only one intersection, which means we're inside. But if I click over here at the left, there is two, which means we are at the outside. So that's how it works. There's a really special case, which is if you click exactly at the vertex right here with this line, which because of floating point numbers could give issues, but it should not be a problem with this simple program. So yeah, we can move the triangle around and check if we're inside by using this algorithm. But let me go a bit deeper into the algorithm. So the way it works is first we look at the vertices in pairs. So we look at vertices like this, AB, BC, and then we also loop to check the last with the first vertex. So that'll be CA, like that. So that's why we have this modulo kind of crazy thing. Then we find the slope equation between these 2 points, these 2 vertices. So the m, which is delta y over delta x. Then we find the intersection with that point. So all we're doing here is finding v, essentially, and we're substituting the y and x of one point in order to find v. We already got the slope, then we gotta find v to complete the equation. We have v, and then we find the x. And in order to find x, we're actually using our point's y coordinate. So what that is saying is I'm clicking here, that's drawing a line to infinity, and in both directions actually. We're counting, we're getting all the x values that intersect. So we're going on a line by line basis. So we start with this one. Compared to this one, are there any intersections? Yes or no? Then compared to this one, any intersections? Yes or no? Then this one. So we go on a line by line basis. And we generate an equation for each line using each pair of vertices. Then I believe here, yes, here what we do is we get the maximum. Yes, we get the maximum and the minimum between the vertices. So for example, here this would be the maximum and this would be the minimum vertex. Let's say we're comparing these two, right? This one's more to the right. So this is the maximum, this is the minimum. And all we're checking is if, because a line equation draws to infinity, like so all the way to infinity. So we're just checking a little section of that. And we're checking if our line that we're drawing at our mouse's coordinate position is intersecting only in this section. So the way to basically calculate a range between that is just get the minimum and maximum vertex in x. So basically limit our equation in x. So once we find that minimum and maximum, all we do here is check, are we within that range between those two vertices x coordinates? And then is that, like I was saying, we should rate to the right only. If we shoot it to the left and right, the algorithm stops working. So we shoot it to the right only, which means it's larger than that x coordinate here. And if it is, we add to the intersection count. And then all we need to do is, if we have an even number of intersections, we're outside. If we have an odd number, we're inside. And that's about it. I also created a custom ray class, so I can do all of my ray transformations. All it has is an origin, a direction, a parameter, which would be O, D, and T for the equation I mentioned earlier. It also has a constructor that just sets like a line width. Oh, I don't need this anymore actually. We don't draw the vector, so no need for that. And that's about it. I also wanted to demo how you can use this for any other shape. So I showed the triangle. Now let me actually demo the movements. So we can rotate left and right, and then we can move in any direction. And we can also go backwards if we need to. And we can do things simultaneously. We can move and rotate simultaneously, which basically lets you have keyboard chords pressing many keys at the same time. So now let's try another more interesting, more fun shape. So let me stop the program from running. My computer is getting kind of slow by recording. And I decided to do something fun, and I brought Patrick Star from the show SpongeBob SquarePants because I said, why not? Patrick he has an interesting polygon shape. So let's check that out. Let me run this program. Okay, so let's start by trying to move him around. So let's click here at the outside. So no movements. Now I'm gonna click here within him, and you can see there's only one intersection with one side. Or what if we clicked here? We're intersecting with 4 lines, so no movement. What if we click here and this tiny corner? Then yeah, we have movement. God, my frame rate is tanking. Okay, how about here? We have 1, 2, 3 intersections, odd number. We're inside. How about here? 1, 2, 3, 4 intersections, even number. Then we're not inside. So this works perfectly with any shape. And then we can also move around as well to any direction we might want. And Patrick can move around the scene. I don't know if he looks like Patrick or more like a arrow. But I just tried to make a cool polygon that could demo all of the features of my code. And yeah, that's about it. I hope this wasn't too long. Thank you.